going to be about the lesson on L'Hopital's rule. And this is just a way to help us determine the limit as x approaches some value. If when when you're able to plug in that value, you get 0 over 0 or infinity over infinity, just these different types of cases that in the past when we did this with unit 2, we had to get a little creative in terms of maybe factoring or multiplying by the conjugate, things like that, or using decimals, like looking at the graph. Where now, instead, since we understand derivatives, we can actually now just look at taking the derivative of our numerator and our denominator and seeing if that allows us to figure out the limit. Okay, so just another way to attack this. Okay, so let's try this one. This one says, evaluate the limit as x approaches 0 of 1 minus the cosine of x over x. So the first thing I do is I just plug in 0. So 1 minus the cosine of 0 over 0. Now, if you forgot, always refer to your formula sheet, but the cosine of 0 is 1. So 1 minus 1 is 0 over 0. So that's this idea that we get 0 over 0. So if you get 0 over 0, then you can apply L'Hopital's rule. All right, now what this means is I'm going to take the derivative, so d dx, of the numerator divided by the derivative of the denominator. The derivative of 1 is just 0. The derivative of cosine is the opposite of sine, but we have that subtraction there, so the opposite of a negative is actually going to be a positive. All right, and the derivative of x is just 1. So now I'm going to do the limit as x approaches 0 of the sine of x over 1. So I'm going to plug in 0. All right, so the cosine of 0 was 1. The sine of 0 is 0. So 0 over 1 is 0. So all of this being said, the limit as x approaches 0 of 1 minus the cosine of x over x is equal to 0. Right, so ultimately, we just use L'Hopital's rule to find it. Okay, let's try another one. The limit as x approaches 1 of the sine of pi x over the natural log of x. So I'm going to plug in 1. So the sine of pi times 1 over the natural log of 1. So the sine of pi, right, if I look at my quadrantals, that's negative 1 comma 0. So the sine of pi is 0. And then the natural log of 1, just like the logarithm of whatever base of 1 is always 0. So again, that's the indeterminate form 0 over 0. So it allows us to use L'Hopital's rule. So I'm going to do the derivative. So d dx of the sine of pi x over the derivative of the natural log of x. And if you need to, I'll go ahead and open it. We can go ahead and look at our formula sheet for derivatives for the natural log of x, which is down here. The natural log of whatever your function is 1 over that function times the derivative of that function. Well, I'll do the denominator first here. The function is just x, so it's going to be in the denominator we have 1 over x, but times the derivative of x, and we know the derivative of x is just 1, so it's really just going to be 1 over x in the bottom. Okay, now let's look at what's happening in the numerator. The derivative of sine is cosine, so the cosine of pi times x, but then times, chain rule here, so I should put these in parentheses, the derivative of pi x is just going to be pi. All right, so if I clean all this up, you get the limit as x approaches 1 of, in the numerator, pi times the cosine of pi times x all over 1 over x. I'm going to plug in 1, so pi times the cosine of pi times 1, which is really just pi, all over 1, which is just 1. All right, so that's going to be equal to, we have the cosine of pi is negative 1, right? If you think about your quadrantals, pi is at the ordered pair negative 1 comma 0, so cosine of pi is negative 1. So this is negative pi, and 1 over 1 is just 1. So to get our answer here, the limit as x approaches 1 of the sine of pi x over the natural log of x equals the opposite of pi. Okay, let's do one more similar to this. Okay, so in this one, we have the limit as x approaches 0 of the sine of x minus x. I'm going to plug in 0. So the sine of 0 minus 0 over 0 squared. Well, sine of 0 is 0. We know that. 0 minus 0. 0 squared is 0. So that's all 0 over 0. Okay? So I'm going to find the derivative. So d dx of sine x minus x over the derivative of x squared. Derivative of sine is cosine. Derivative of x is 1. And then the derivative of x squared is 2x. So now I'm going to plug in 0 again, cosine of 0 minus 1 over 2 times 0. Now this one's interesting. Watch what happens here. This is kind of cool. Or at least I find it interesting. The cosine of 0, we've already talked about this. The cosine of 0 is 1. So that's 1 minus 1 over 0, which again is 0 over 0. So actually what's kind of cool about this, you get to use L'Hopital's rule twice. So now I'm going to do d dx of cosine of x minus 1 over the derivative of 2x. So we get to use it twice because we had 0 over 0 again. Derivative of cosine is negative sine of x. Derivative of any constant is just 0. Derivative of 2x is 2. So now I'm going to plug in 0. So the sine of 0 is 0. The opposite of 0 is still 0. 0 divided by 2 is 0. So all of that was a lot, I know, to say the limit as x approaches 0 of sine of x minus x over x squared equals 0. Okay, let's keep moving forward. I'm going to change it up just a little bit here. Now, this next thing is saying that you can use the same idea if, when you do this, instead of getting 0 over 0, you get infinity over infinity. Okay, so it's the same kind of idea, just now we have a different case. Okay, so for this one, all right, we're going to look at plugging in infinity. So if you just plug in a really big number and multiply it by 3, okay, and add 5, you're going to get a really big number. So that's going to be infinity. And the limit as x approaches infinity of 2x plus 1, again, a really big number times 2 is still a really big number, plus 1 is a really big number. So we have this case, infinity over infinity. So that allows us to take the derivative of 3x plus 5 and look at the derivative of 2x plus 1, and we get 3 over 2. So the limit as x approaches infinity of 3/2. And one of the very first rules we learned with limits is that no matter what you're approaching in terms of your limit, if you're looking at the limit as x approaches anything of a constant, then it will always just be that constant. So this is going to be 3/2. All right, so that's our limit as x approaches infinity of these two functions divided by each other. Okay, let's show you what happens when a limit cannot be evaluated using L'Hopital's rule. All right, so when you guys would have done this in Unit 2, all right, you would have plugged in 1, so 1 squared, plus 5 over 3 times 1, plus 4, which gives you 6 over 7. So the answer is 6/7. Now, if you use the L'Hopital's rule, which you would not, right? You didn't get 0 over 0. You actually got a limit, so you're done. But if you decided to, like, mistakenly think you could use this rule and take the derivative of these two functions, you would get 2x over 3. And plugging in 1, you get 2 times 1 over 3, which is 2/3. Okay? Now that, you'll notice, is not the same as 6/7. So the key thing is, if you're going to use the L'Hopital's rule, when you plug in your value, that's your limit for x that's approaching, right, whatever that number is, when you plug in, if you get 0 over 0, infinity over infinity, great, you're good to go. You can use the L'Hopital's rule. But if you don't, then you're not allowed to use it. Okay? All right, so that's it in terms of all I wanted to show you for the L'Hopital's rule. I know this is pretty quick, but I just want to show you this like as another way to help us evaluate limits. You'll see on our review for the Unit 4 test that it's just a small portion where I ask you some questions about this rule. But make sure to try some of the homework questions and reach out if you have any other questions. All right, good luck.